Hello everyone. My name is Dr. Rajat Dandekar and I'm a PhD graduate from Purdue University. So in this session, I want to just give a brief overview of a recent paper which I have been reading. And the title of the paper is STAR, which is Self-Taught Reasoner Bootstrapping Reasoning with Reasoning. So I was mainly interested in this paper because I was seeing one of the interviews of Arvind Srinivasan, who is the CEO of Perplexity, and the discussion was regarding how do we know whether ChatGPT or any language model is coming to the answer with the right series of steps. So generally, what happens is that if we give a prompt to ChatGPT, ChatGPT gives an answer to that prompt. However, we do not know what is the thought process behind that prompt. So what I mean by this is that, let's say you have given a prompt and you get an answer. Now, if ChatGPT is giving an answer by truly understanding the logical thought process from the prompt to the answer, then that is fine. But what if the answer that you are getting is just based on a sort of a mapping from the prompt to the answer without really understanding what's happening in the process in between? And if that's the case, then we cannot say that language models are intelligent, because they are going from point A to point B without really understanding the series of thoughts in between. And that is how humans tend to think. If, let's say, we are asked a question and we give an answer to that question, it is based on a chain of thought, right? And we are not sure whether ChatGPT is giving an answer that is based on that chain of thought, or it's randomly giving us an answer without really understanding what's happening uh, in the process of thinking. So the question that people are trying to grapple with is that, does ChatGPT really have intelligence, or it's simply a mapping that is being done from an input to the output? And that is what mainly attracted me to this paper, because what they have done here is that they have proposed a technique to iteratively use a small number of rational examples and a large set of data without rationals to perform more complex reasoning. So, what does that mean? So, they have actually mentioned this very nicely in this diagram. So, let's say we give a question to the language model, and the language model will give a rational along with the answer. So this is the answer that is fine, but there is a rational which comes along with it. For example, if we ask the question, what can be used to carry a small dog, and then we give four options like these. So what we have over here is that we have a rational which is mentioned in red over here. The rational says something like, the answer must be something that can be used to carry a small dog. Baskets are designed to hold things, therefore the answer is basket, which is option number B. So we have the answer which is option number B, that is correct, because a basket is indeed used to carry a small dog. But there is some rationale behind it, right? And that is what we are trying to really understand here. We are trying to sense whether ChatGPT is able to give an answer along with the rationale and not just the answer associated with it. So okay, so what they have done here is that, let's say you ask a question and then the language model gives you a rationale along with the answer. There are two possibilities, right? If the answer is correct or the answer is wrong. If the answer is correct, then the question along with the rationale and the answer is again fed back to the model to fine tune it. If the answer is wrong, then what happens is that the language model is given the correct answer, and then it backtracks to find out the actual rationale behind it, and then that information is again used for the training. So for example, if we ask this question and then the model answers wrong, let's say it answers dog show, so we know that it's a wrong answer. So what we do here is that we tell the language model that the correct answer is basket, and then it backtracks the rationale from it, and then we again give that as an input to the language model, and then fine tune the training data based on it. So that's why they say this technique relies on a simple loop: generate rationals to answer many questions, prompted with a few rational examples. If the generated answer is wrong, then try again to generate a rational given the correct answer, fine tune on all rationals, and ultimately yield the correct answers and repeat. So, through this process, what they are trying to do is that they are trying to impart reasoning capabilities to language models. And reasoning is one area of intelligence which human possess. But the question is that can language models actually reason, and can language models reason? And this is the question that we'll be trying to answer as a part of this paper. So just to give you a more uh, practical understanding of what do we mean by rationals, there are a bunch of examples which they have given towards the end of this paper. So let's look at some of these examples. Okay, so let's say there is a question that we ask: what might what might someone gain from learning about science? And the answer choices are, let's say, headache, seeing things differently, increased knowledge, accidents, and appreciation of nature. So I would tend to answer increased knowledge. And okay, so this is what the language model does. The language model gives us the correct answer. It does say the answer is C, but look at the rationale that it generated. It says that the answer must be something that someone would get from learning about science, which is true. Learning about science would increase knowledge, and therefore the answer is increased knowledge. So this is good. I mean, I'm really satisfied with this kind of a rationale. Now, if you look at the second question, the Christian rock band was on a large stage. The singer's foot got caught on a wire, and he had a small wart. So we know that the answer is stumble. He had a small stumble. Now let's see how the language model got to it. The answer must be something that would cause the singer to stumble. So you can see that the answer is directly included in the rational, which will never be the case. When I'm trying to rational, I can say that okay, the singer's foot got caught on a wire. So it should be something that indicates that the singer is falling. Therefore, the answer is option number D. But here what's happening is that the answer is coming in the rational itself, which means that you don't really understand what's happening in the background. And there are a lot of examples which they have given. uh, and here is another example where it doesn't really understand what's happening. So let me okay, so let's take this example. A person hands hurts after hitting the bottle. What might happen to the bottle? And the answer choices are alcoholism, breaking, nausea, and ticket. So what might happen to the bottle? We know that the answer is breaking. So it says the answer must be something that happens to the bottle. The bottle is broken, therefore the answer is B. And here, okay, it has got to the right answer, but the rationale should be something like when the bottle a person hand hurts after hitting the bottle, so it means that the impact of the hand in the bottle would cause the bottle to break, and therefore the bottle is broken. So here also it's kind of okayish, but it's still not completely convincing. Okay, and there are many examples here where they have given how language models give rationals, and before they give us the answer. Okay, so they have done some further analysis on this, and here is something interesting. So what they say here is that they have these human evaluated test prompts. So what they do is that they select a random sample of 50 questions which were correctly answered both few shot and by a star trained model without rationalization, presented in a random order. They uh, they ask whether they ask the human participants which answer do you prefer. And let's try to see. So, who is likely to have a caring heart? We have person, species, artichoke, all mammals, and live animal. And mind you, one of them is written by a human, one of them has been written by their algorithm, which is star, and then one of them is written by few shot training. So, let's see. The answer must be a person. All mammals have a caring heart. Therefore, the answer is person A. Okay, so here also the answer, you can see that in the answer they have or in the rational they have directly included the answer, which is a bit unlikely. The answer must be someone who is likely to have a caring heart. Humans are the most likely, therefore the answer is person. So you can see second one is much more convincing than the first one. It is much more logical. Third one, a person is the only human being capable, and therefore the answer is person. So I think that the star, this is the one which is written by star, and this is better. And then this is the one which is written by human. So what they claim is that after we fine tune the language model based on our uh, our feedback loop, the rationales which the language model gives before presenting the answer is much better, as opposed to if you do not carry out the rationalization or the feedback loop process which they have outlined as a part of this paper. And I have tried doing this activity for several of these questions, and it really works. And they have a lot of questions and answers like these which are very interesting. They were solved by humans. There are 50 questions which are there over here. Okay, so here what they have done is that they have included some examples of rationalizations. So here uh, we can see several examples. So let's look at the first example. Why do I eat just enough when eating breakfast? The answer must be a reason for eating just enough when eating breakfast. Eating just enough is a way to feel satisfied. Therefore, the answer is feeling satisfied. So this is also decent enough. It's correct. How is a dog likely to communicate with another dog? The answer must be a way for dog to communicate with another dog. Dogs bark to communicate with each other. Therefore, the answer is bark. So these are all examples of rationals which the uh, model is coming with, which are decent. So here let's try to read what's happening over here. We include a randomly set of rationalizations, randomly sample set which the model is able to produce before fine tuning. We observe that sometimes the model constructs an argument roughly of the form the answer must have a set of properties, correct answer has properties, therefore the answer is correct answer. The structure of argument is fairly standard, but given the model originally answered these questions incorrectly, it resembles template matching more than reasoning. The technique of rephrasing the question in a simpler way before answering it directly is also often effective. In general, the rationals from the pre trained models appear to be of similar quality to the pre trained model's rational generation. We therefore reference the pre trained model here rather than star trained model, as the final iterations rational are the one which the model struggled to learn from. So these are some of the rationals which are being generated uh, after the model is trained, after we are using the star technique to train the model. So just have a look at these examples first. They are very interesting, and they help you to understand what's going on in this paper in a better manner. Uh, okay, so I'll just show you this algorithm quickly so that you can understand what's happening. Okay, so what the algorithm really says is that, let me actually go to this. Yeah. So what they have essentially done is that we have been given a pre-trained LLM. Okay, assume that it's ChatGPT which is pre-trained, and then we are providing an initial data set of problems, which are these xi yi. So why are these problems given data set? Because we have to feed the model with the input, the output, and the prompt associated with it. So our technique starts with a small prompt of examples. So these are the xi is of course a part of this data set, yi is a part of this data set, and ri is the rationals. So we are giving the rationals here by ourselves, and these are called intermediate rationals. So let's say if d is 20, then p is 10, let's say. So there are 10 examples which are given to the model, and like standard, we concatenate this prompt set to each example in d. So you can see that now whichever examples are there in the data set are being augmented with these prompts. So xi, yi, out of these, there will be 10 inputs which will be augmented with these three. Okay. And what this will do is that this will encourage the model to not just give an output. So let's say now we again feed these as the input to the model. Then the answer is not going to be yi because the model is pre-trained. It is going to be some y hat, and along with that it's going to produce a rational also r hat. And here there are two possibilities. If y hat is equal to y, then it's good, then we again fine tune the model with the same set. But there is a second possibility that y hat is not equal to y. So what they do is that we assume that rationals that lead to correct answers are of better quality. Therefore, we filter the generated rationals to include only the ones which result in the correct answer. And then they fine tune the model based on this filtered data set and restart this process by generating new rationals with the finely tuned model. So you can see what is happening over here. We have a data set which we are augmenting the input data set with, and in this data set there will be some examples where the output is matching. In case the output matches, then we fine tune the model on this filtered data set. Essentially we are trying to make the model more biased towards uh, inputs and outputs where the prompt is correct. So here the assumption of course is that if the answer is correct, then the prompt is also uh, like rationals that lead to correct answers are of better quality than those that lead to incorrect answers. So essentially by doing this process more and more number of times, we are hoping that the model will only give outputs for cases where the rationale is correct, as opposed to giving outputs where the output is uh, not matching with the ground truth data. And this can be expressed in an algorithmic form like this. So here what's happening is that, let's say this is our original pre-trained model M0, and then what we do is that we for every input xi, we have two variables as an output, y hat and r hat. Okay, now ignore the blue lines for now. If y hat is equal to y, then the data set is changed to xi, yi, and this rational. Okay, and then the model is trained again by taking a union of the original pre-trained LLM and the new data set for which y hat is matching y. Now, in case y hat is not equal to y, then there is a step called rationalization which is done. So, what does rationalization mean? So, here what they have done is that, so let's say y hat is not equal to y, which is this. If y hat is not equal to y, then we have another data set called d superscript rational, where we have xi, yi, but along with that we have these R rat, which is the rationals, and you can see that these rationals are mentioned in this fourth step over here, which are produced after adding the hint. So if the answer is wrong, you are giving it the correct answer by providing the hint, and then you are asking it to come up with backtrack and come up with a different rationale, which is then added to this data set. So finally, the data set that is fine tuned with is a union of dn and dn rational. This is all. This is the basic concept of this star algorithm, and they have got a significant improvement. So you can see here, these are the two examples of where they are visualizing accuracy of n digit summation. So for example, one digit, two digit, three digit, etc. So just look at, let's say, the yellow curve, which is two digit summation. So here what's happening is that if you try to superimpose this, the curve on the right is probably looking something like this, which means that for every iteration, the accuracy is much higher compared to without rationalization, which means that rationalization is improving our accuracy. And not just that, we are able to now uh, confidently say that whatever answer ChatGPT or any language model is giving, it is probably reasoning in the right direction. So I encourage all of you to just have a read through this paper. I think going forward, we will be moving in a direction where language models will evolve to make sure that they are able to reason properly, and it's not just a simple direct mapping from an input to output. And one of the things which I was recently thinking about was that, uh, let's say we are given a complex problem, which is very complex, and it takes us a lot of time to solve. So initially we tell someone that we are not able to solve it, and after a long thought process we are able to come up with the final answer. So are language models capable of doing this currently? Maybe not. We saw some example of this when recently uh, language models were able to actually solve international maths olympiad problems after multiple hours, but they are not very fine tuned either. So I think we are moving in the right direction, and papers like these will become more and more important moving forward.